All right, everyone. So please help me thank James just for the great line. So today we're going to go through data structures, but before that, we're just going to touch on a couple of public announcements. So the first is we've been updating the course website just with the slides. So if, for example, you want to look at previous day's slides, we usually post it about an hour or so just after the class, so just when we finish the class and remember. But you can actually just go to that link there, and we have posted all the slides we've been using. That just helps with the revision. And just if you miss anything or there's anything you want to take an image of, feel free to take a look at that. So this is actually just a bit of a taster to what CS actually feels like later on. But James talked a little bit about this morning on Boolean logic. And you can actually start to construct really advanced functions using just Boolean logic, right? And computer science actually came from this field. So this field preceded computer science. And there's actually all sorts of special operators that you can use in mathematics, which actually provides you really powerful tools to do Boolean logic. And you can create these what's called truth tables, which is given different inputs. For example, A and B being false or true, so 0 being false and 1 being true. You can actually build, for example, an AND truth table that is only true when both A and B are true, for example, an OR table that accepts, either A or B being true. A SOR table, which means that it's exclusive OR, meaning you only have A true or B true, but if both are true, then it's actually false. And then a not true table, which converts 1 or 0 backwards. And it's also really important in electrical engineering when you're designing components for digital logic. You actually use these truth tables to basically flip values, basically have, something that's, for example, a voltage of 1 turn to a voltage of 0, flip back to 1. So that sort of logic is really critical in both computer science and electrical engineering. All right, so just a brief note about variable scope. So we've been saying that variable scopes, in particular for variables, actually stay within the function, but it goes one level deeper as well, and we'll go for an example of that right now. So can you just work in your teams just to think about what this would actually print? So this hopefully should just be a very quick revision. All right, great. So can someone just share if they're confident what this prints? Yeah.
So it's going to start off with the first iteration of logic loop. Then which is then going to do every iteration of the inner loop. So it'll be 0, 1, 2, 3, 4, and then it'll be I, which is 0.
Yep.
Then it's going to repeat the loop, but instead it'll be the second iteration will be outer loop. So it'll be 0, 1, 2, 3, 4, 1, 0, 1, 2, 3, 4, 2, 0, 1, 2, 3, 4.
Perfect. Yeah, so just to sort of reiterate that, so obviously it wouldn't print a new line every single time. We'll go through what that means later in the string section. But basically you have the J loop here, which is 0, 1, 2, 3, 4, and it does that 5 times, right? Because it's nested in the double for loop. And then this outside one only runs once at the end, and it's sort of this column here, that's 0, 1, 2, 3, 4, okay? So my question is, what happens if you do this? So I've written a note there, which is variables are local to their own code block, okay? So, exactly. So it actually leads to an error. And the reason why is that when you define J here, for example, right? It's actually only local to anything that's indented in this code block. So in this case, we don't have an indent, meaning that it's outside of this for loops code block. And so therefore, this will throw up an error, okay? And then same with this here. So again, I has been defined in this code block in particular, right? And because it will only exist in this section here, if it is outside of the code block, then it will also throw up an error and Python won't know what I you're referring to. Okay, so we've been talking about this in the range of functions, but it also applies for loops. If, for example, you define something inside a for loop, then it doesn't apply outside or it doesn't exist outside of that for loop. Okay. So let's go through an example of what that actually means. So let's take a look at this. So what exactly would print here? Have a think about it. Anyone just want to yell an answer? Yeah, so why is it an error?
No, it's for the Y, it's print Y. It's asking for what, so.
Yes. Yeah, exactly. So it's the same principle. So in this case, for this, for example, for Y, we define Y inside a for loop, which means that it's inside this code block. Okay, so variables are local to their code block, meaning that if, for example, you move outside of the code block, and remember, code block is just, it's indented after a colon, right? And if you move outside of the code block now, Python doesn't know what Y is anymore. Okay, and it's the same here. We define X inside this for loop code block. So if, for example, we were to change this to print X, it would know what X is. But because it's outside of the code block now, X no longer exists as soon as you move it outside of that code block. Okay, so in this case here, what if we want to count how many times we print anything? How would we do so? So think about it, we need to have a variable that obviously, for example, increments here, right? Every time we print something, it just adds one to the counter, right? But how do we make sure that with the variable actually persists throughout the whole for block? Yeah.
There are within store J range 5 after the print J.
You can increment. Yeah, so where would you initialize the count?
I probably just do it like
Yeah, so you can do it globally. So the very easy answer is you simply initialize the variable outside of the loop. Okay, so that's where you have to do it. And the reason why is because if you initialize it outside here, then it persists throughout the whole block. Okay, and it knows what n is referring to every time it calls it. Okay, and then if, for example, you want to print the number of times it's been printed, which in this case would be 25, right? Then n equals 0 here, it will add 1 every single time it runs through this line of code, and then you can access n again outside here. Okay, so this is a very common pattern when you're dealing particularly with for loops. You want to make sure that if you are having a variable that you need to access outside of the for loop, you initialize it at the start. Okay, and this is really important for data structures because, for example, if you're working with a list, which we'll go through in a little bit, you do want to initialize the list outside of any for loops, outside of any code blocks. Okay, because you're going to be operating on that list and then referring to it later. Okay, does that make sense? All right, fantastic. So what exactly are data structures? So data structures represent very powerful ways to organize data. Okay, so for example, we have what is called a list, which is merely just a one-dimensional matrix or vector, right? Which stores certain items in a comma-separated method. Okay, so for example, it's represented in this case by the square brackets. Okay, and we'll talk a little bit more about that and how Python interprets it. But it basically just has an object, comma, object, comma, object, comma. And this is one of the most common data structures in Python because, as you can imagine, any type of data, you can pretty much represent it as a list. Okay, whether it's, for example, an Excel spreadsheet or an Excel column, right? Basically represented as a list. Now, we also go through what's called dictionaries, which basically assign one value to another value. So we call the first value a key, then the second value, the value, right? And so, for example, if we want to store different lists of names and what the profession is, we can store it in what's called a dictionary. So, for example, Alice is a surgeon, Bob is a nephrologist, and Carmen's a GP. And it forever links those two values together. Okay, so that every time you refer to Alice, then you can return surgeon from this data structure. Okay. All right, now there are a lot of other advanced data structures as well, which we won't really go through today, but you might see out in the wild. So for example, this is called a direct acyclic word graph or DOG, right? Which actually is used in iPhones to basically auto-complete words, okay? So what it does is it accepts words that are true words. So for example, if you follow this, TOPS, tops, right? Or you could have TOP, that's a word, right? TAPS, taps. So this is actually how iPhones very efficiently store words within the iPhone, right? And it also recognizes what an actual word is. So you see how there, it's actually every line of the graph is actually a legitimate word in the English language, okay? So this is another really cool structure. Social networks rely on what are called graphs, okay? So graphs basically map out the different connections between different people. So for example, if you're on Facebook or LinkedIn, it actually has a giant graph in the background which connects you. So if you've ever seen LinkedIn before, it tells you that, for example, your second degree connection, third degree connection, all that's saying is that you are, for example, 2 or 3 people away from another person. Okay, so that's a graph. Graphs can also be really useful to map out networks. So for example, if you have an internet server or anything else or social network, you can have different structures. So for example, you might have a network which is centralized. So for example, there's just like a single server that services all these homes, right? You could have a decentralized network. So you have all these nodes that actually are decentralized. So it's separate out and they only take care of 4 or 5 different homes. And then you have a peer-to-peer network, which is everyone's connected to 2 other people. So it's a small number of connections, but there's a lot more connections. Okay. Now, networks actually seem to be very useful for biology as well. So this is actually from a Nature paper where we map out different cellular functional networks, right? And so graphs are actually really useful to map out things like biological processes, how cells actually work, how genes communicate, how proteins communicate as well. And so this is sort of something that eventually you might learn, and graphs can be very useful, particularly for research. All right, so today we'll be going through some of the basic data structures in Python and some of the most common ones that you use. So we'll go through lists. Now we've covered strings already. Strings are considered a basic data type, right? But strings have a lot of functionality and power behind them. And so we'll actually really do a deep dive into strings, which is really useful. And then we'll go through dictionaries as well as attributes. Okay, so how we import things, how import actually works, and then get you to get a bit more familiar with that. So let's go through lists. So lists are an ordered collection of items. Okay, and those items can really be anything. So in some other languages, when you have a list, you can only have, for example, numbers in them or strings in them. It's strictly defined, but in Python, you're allowed to have anything. Okay, you can have, for example, a number in the first position, an emoji in the second position, right? In the third position, a string, whatever you like. Now, how Python tells that you have a list is that it looks for the square brackets. Okay, so you can't use squiggly brackets, you can't use curved brackets. The square brackets indicate to Python that it's a list. And the items are separated by a comma. Okay, sometimes you might see the word array used as well. Array is sort of an older data structure in other languages, but some people just continue to use the word array. They usually mean this. Okay. Now, for example, we have a list of numbers here, but we can also switch it to a list of objects or strings. Okay. Now, in this case, it's a list of objects or variables because we don't have the apostrophes. Okay. Now, we can also have completely different variable types in there, and this is specifically a Python thing. So I've just put the Python marker there, whatever is the special Python thing, right? Because in other languages, you can't get away with such sloppiness, right? Python does allow you to do it. In this case, we can have a variable called qua, then an emoji with the doctor, and then a number, set of numbers 1, 2, 3, 4. Now, list with one element, so an element itself, so 1, 2, 3, for example, doesn't equal a list with that element. Okay, so keep in mind that on the left-hand side, we have the type integer, but then on the right-hand side, it's a list with an integer. Okay, so they're not the same thing. And that's one thing that is often very much a bug. We have to be careful about. Lists can be empty. So when you first initialize a list, you actually have to create a completely empty list. You can create a list that has something in it, but more often than not, you're creating an empty list, okay? Because you want to start afresh. And so you can create an empty list just by simply having the 2 square brackets with nothing inside, okay? Now, lists are very powerful because they are indexed by a number, okay? So remember that in Python, we start counting using 0, okay? So the first index is always 0. And then the second index is 1, 2, and then 3, okay? And the way to index is by having, say, for example, you initialize a list as 1, 2, 3, 4 like this. To index it, you recall the list, and then you use the square brackets and then put a number inside, and then end the square brackets. And that's how you actually call different values from the list. So can anyone guess what list 0 would return? Yeah, 1, perfect, exactly. So list 0 in this case says I want to access the item at position 0 in list. Okay, so in this case it'll be 1. What about list 1? 2, perfect. List 2? 3, perfect. List 4? Error, perfect. So in this case, even though we have 4 items, remember that Python counts from 0, And so 0, 1, 2, 3, 4 is actually the fifth item, confusingly a little bit, right? And we don't have a fifth item, okay? And so therefore, this will return this specific error. So index error, list index out of range. So if you ever see that error, it just means you're trying to index a value that doesn't exist. Okay. All right. Now you can also change with indexing as well. So for example, if we have this list here and we say list 2 equals 8, remember that this equal means to assign something. Okay. So Python looks at the right-hand side first. It says, all right, that's an 8. And then it looks at the left-hand side and goes, all right, list 2 is now going to become an 8. Okay. So in this case, it just switches to an 8 like that. Okay, so that's actually how you modify this. Okay, so that says, please change the item in position 2 to the number 8. All right, list 0 equals cap. Where would the cap go? 1. So we'll replace the 1. Perfect. Okay. All right, so let's take a look at what each does here. So let's refresh. What does the left-hand side equation do? Or what happens if you write the left-hand side? What does that evaluate to in Python? Return the alien, exactly, right? And then what does the right-hand side do in this case? Swap the alien for the other alien. The Space Invaders alien for the new alien. Perfect. All right. So Python also allows negative indexing. All right. Now this is not possible in other languages, so just be careful if you're ever working in C or whatever, you're going to do this, right? But it actually allows you to index from the back of the list. Okay, so why would this be useful? This will be useful in particular when you have a very long list and you want to access the end and you don't want to figure out what the length of the list is. Okay, so in other languages, you have to figure out the length of the list and then -1. So for example, if it's 50 long, you have to figure out it's 50 in code and then -1. But in Python, it actually just allows you to directly go, what's list -1? Okay, and now when it counts backwards, one thing to be aware of is it doesn't start at 0. Okay, it forces this first one to be 0. And if you count backwards, this is -1, -2. And the reason for that, obviously, is if that's 0 as well, and you try and access 0, Python doesn't know, are you trying to refer to that or that? Okay. So what is list -1 in this case? Yeah, 4, perfect. List -5, out of index. Okay, so it's the same sort of principles. If you try and access something that doesn't exist, then it will just return an index error. All right. If now we change this -3 to dumpling, which value will change? 2, perfect. The switch is done. All right. Now, what if I write something like this? What would it evaluate to? Yeah, so this is a Boolean. So remember, if you have the double equal sign, it's a Boolean, right? And you're checking if something is true. Okay, so in this case, it checks the right-hand side first. So list -3 is a dumpling, right? And this one is also a dumpling. So therefore, it will return true. All right. Perfect. Now, what if you want a slice of the list? So Python also allows another complex type of function called slicing the list, which means that you actually take a small slice of it. So just imagine like a piece of bread, right? You take a slice of it. How that works is that Python inherently has a set of numbers that you can use in here. So again, if you move the slices actually from the numbers to the space in between the numbers, you can collect 0 to 2. So 0 to 2 here, meaning that you collect this part of the list. Okay, so I'll repeat that again. So if, for example, you call this 0:2, it basically takes these two numbers here. Okay, another way to look at it as well is it includes the first item, but it doesn't include the second item. Okay, so that is if 0 to 2 means that you call 0 and 1. Okay, so index is 0 and 1. So any questions on this part in particular? This is getting a little bit tricky in terms of lists. Okay, cool. Now you can also negative index for lists as well. And again, what it does is it basically goes, all right, so 0 is the start point. I will include this number. So 1, 2, and then -2 is this number here. So recall that -1 is this, -2 is this. I'm going to stop before -2. So it's exclusive of that second number there. Okay. Any questions?
Yeah, actually, 0 to the top right.
Yeah, so with this one here, what I've done is shifted the numbers just so it's between the gaps. And theoretically, Python actually shifts this 0 and -1 to between the gaps. So this corresponds to -1. And here, like there's a 0 there. That's one way to look at it, but maybe that's more confusing. The other way is if, for example, you just go, okay, this is 0, 1, 2, 3, -1, -2, -3, -4. So 0 to -2 means that you include 0, you exclude -2. Okay?
You would start with a zero.
Yeah.
Right.
Correct. Yeah. All right. Now, if, for example, you have a missing n in slicing, then it just assumes that you want to go all the way to the end. Okay? So if we call this 2 to the end, it will include 1, 2. So the second, so 0, 1, 2, the second value, so 3, and then it goes all the way to the end. Okay? If it's missing the first value, then it assumes that you want to start from the beginning of the list. Okay? So for example, this 2 will basically go 0, 1, and then it doesn't include 2. Okay? All right, and then you have an optional third value, which also means that you can indicate what step you want. Okay, so say we have 0 to 4, meaning we want the whole list, but we have a third value there, which is 2, which it means that we'll skip a step. Okay, so for example, if we have 3 here, then it will skip 3 values to 4. Does that make sense? All right, some confusion there. All right, so this value here indicates the start value. This value here indicates the end value, non-inclusive, right? And then this indicates the step size. Okay, step size meaning, for example, if this is a 1, then you go through each individual value. If the step size is 2, then every time you take a step, you skip a value. Right? Yeah.
Is it possible to do like 2 to -2 or 2 to -1? Like, I think it's possible to start reading in the middle of the list and then go around, loop around.
Loop around, no. You can only go one way. Yeah. Yeah. A great question. You can also go backwards as well. So for example, if this is -1, right? Essentially what will happen is we'll read here 4, and then we'll go backwards to 3, to 2, to 1. So that's a very easy way, for example, to reverse the list, right? Because you're just stepping backwards. Okay. You can also use -2, for example, in which case will be, we'll start here, and then we'll go, all right, 1, 2, and then we'll include only these 2 values here. Okay. Yeah, so these are sort of nifty tricks you might see. Again, less used, right? But it is something that might be useful, particularly if you look at the word name. Okay. All right. So, spend some time and see if you can figure out what the output of this is. So what does this actually look like, or what will this print at the end of this function? Okay. So hopefully we've had some time to think about it. So I'm gonna go the old fashioned way and just start writing here. So 1, 2, 3, 4, 5. Now, what might help is to actually write down the index. So this is 0, 1, 2, 3, 4, -1, -2, -3, -4, -5. Okay. So the very first step is we're going to switch this to an alien. Okay. So I'm just going to say A here for alien. All right. Any questions there? Perfect. Skull. Oh, sorry. Skull. Yeah. My bad. Skull. Right there. All right. Skull. And then list 0 equals skull. Okay. So list 2 equals list 1. So we're saying that this value should change to this value here. Right? So what that means is that we're going to have a 2 there. Any questions? Perfect. Okay, the next step is that -4, so this value here, is going to equal this value here. Okay, so this will change to a 5. And then the final step is we're going to print list 0 to -2, where we don't include -2, right? So all that will print is the skull, 5, and 2. Okay, any questions? Cool, awesome. So hopefully that was relatively straightforward. No, it simply just prints this. Right. With the square brackets as well. Yeah, and the commas. Okay. Okay, perfect. So that's the answer. Right, so try your hand at this one. This one's a little bit trickier now. All right, so let's spend time going through this one. So this one here, again, we start with 1, 2, 3, 4, 5. Okay. So the first line, or the second line rather, says that list 0 equals list 1. Okay. So list 0 will now change to the value in list 1, which is 2. Okay. Then the third line says if list 0 equals 2, which it does. Okay. Then we change list 2 to 3, which it already is. Okay, so we don't need to make any changes there. And then it says print list. And recall that if there's a missing value there, then it assumes that it goes from the start of the list. Okay? 2, the third position, non-inclusive. Okay? So this will print 2, 2, 3. Does that make sense? Perfect. All right. So let's go through a little bit more about lists, how it works. So recall that there are 2 ways to call functions, okay? So we've primarily been talking about one, which is to define your own function and then use it, right? But you may have seen other functions, particularly when you're calling different libraries, but there may be a dot. So for example, this would be our function that we've defined here. But if we want to do like a random, if you've noticed, it's like ran.ranInt and then params. So the second is what's called a method, and we'll go through a little bit more about this tomorrow. But when you create a new class or you create a new package, what you can do is you can define a specific method attached to an object. Okay, so for example, later on, we'll see some string methods where we say string and then, for example, sort, or string and then length. Okay? And basically what that means is that this function is always attached to this object. Okay, so it's specifically and specially designed for that object. Okay? If you see this, this usually refers to a general function where you can apply it to almost anything. Okay, slash it has very clearly defined behavior where it's like you can only use it for math or you can only use it for something else. Okay, but this object, for example, you might have seen math.py. Pi is a specific thing in the math library. Okay, so it just attaches that function to a specific package or specific object. Okay, so that information will come useful later, but let's take a look at how we actually add items to this list. So how we can add items is we use something called list.append. Okay, so in this case, recall that this is a dot operator, meaning that this append function only works for lists. Okay, and in this case, we define list first as an empty list, and then we append the value 1 to it. Okay, if we append the value 2 to it, then it adds 2 to the end. Or if we add 4, for example, then it adds 4 to the end. Now, removing items, how we do it is we can just use list.pop, and then it removes the final item from the list. Okay, and then we pop again, and we pop again. Okay, so that's actually how you remove items from the list. And then we're back to an empty list. Yeah. Okay, yeah. So for example, if you want to list pop specifically this value here, recall that this is index number 1. Okay, so 0, 1, 2. If you want to pop a specific index, you go list.pop 1 and then removes the number 2. Okay, so I'll just repeat that again. This is referring to the index, not the value. Okay, so list pop 1 means that you're removing the first item. Okay, so for the item in the first index. So in this case, 1, 2, 4 would become 1, 4. Right, if you, for example, pop the 0th index value, then you get rid of the 1. Now you just have a 4. All right, extending lists. So say you have list 1 equals 1, 2, 3, and then list 2 equals 4, 5, 6. What do you expect to happen if you append list 2 to list 1? Yeah, this, yeah.
So it will be a list of all included in the list. So
Yeah.
Okay.
Exactly. So this is a very subtle thing to realize, but may lead to a lot of bugs in your code, which is when you append something, recall that we were appending specific numbers. Okay, so for example, if you append 4, it just simply attaches 4 to it. If you try and append another list, then what's going to happen is you basically have a list within a list. Okay, so it's just something to take care of once you're dealing with append. The way to do this properly is to use extend. Okay, so as you can see, list has all sorts of different functionalities, and you can read about it on the list method site, right, which we'll go through in a little bit later. But it has different functionalities that you need to be aware of. Okay, if you want to add 2 lists together, you have to use extend rather than append, because append will lead to that, right, which is often what you might not want. All right, another way to do it as well, instead of a pen, is to simply use the concatenation operator, which in this case is just the addition sign. And if you say list one plus list two, then it will work nicely and give you a proper list. Okay. All right, another way to do this entirely is to use the increment operator, which means that you just go list one plus equals list two, and it adds list two to the end of this one. Okay. All right. So what do we think happens if we try and get the length of the list? Exactly. It returns an integer that is the number of elements in that list. Okay, so sometimes that's very useful. So note how len is a more general function, right? It's not attached to lists. And so len is more generally defined in Python, meaning that you can actually use it for lots of different things. And there is inherently a a length within most objects. Okay, so for example, if you're dealing with dictionary, it's going to be how many items you have in there. If it's a list, it's how many array, comma separated items you have, right? So if we take a look at this will be obviously 4, right? What about this? What would the length of this list be? Also 4. Okay, so how this works is it just looks one level in. Okay, it just goes, okay, that's 1 item, that's 2 item, that's 3 item. It looks at the commas. That's a single item there. Okay, even though technically we have 5 numbers in here, like a human looks at this and goes, there's 5 items in here. Python just simply looks at those, all right, 1, 2, 3, 4. Because this is not comma separated by anything else. It does have a comma inside the list itself, but it is an object. Okay, it's seen as an object by Python. Okay. All right, what if we did this instead? So I'm hearing some potential answers. So let's take a look. So in this case, we go list one. So remember when we evaluate in Python, it's inside out. So list one is 0, 1, 2, 3. So we're talking about this item in particular. And if you get the length of just this object here, it is 1 and 2. Okay, so the answer will be 2 in this case because it's a list with 2 items. Okay, any questions? Perfect. All right, so printing lists. So print is another general function whereby you can use it on a lot of different types of objects. So for example, if you print a list, then you get a certain thing. If you print a dictionary, you get a certain thing as well. In this case, if we have list here like this, if we print list, it simply prints this to terminal. Okay, including the square brackets and the commas as well. Okay, so it's very useful, for example, to look at how lists are behaving just by simply printing it. Now you can also print individual elements in a list as well. So for example, if you go print list 1, then you get it 2. Okay, so it basically extracts out that object and then prints it. Okay, so let's take a look at this. So please try your hand at what list will look like at the end of this.
Don't try this thing because some people I don't know. Does it? Yeah. Okay, don't try it. You're gonna figure that out. Yeah, I'll try. Let's figure this out. It's advanced. I don't know. Okay. Yes, try that. I think this is with the like white buttons. Should we just write on the this? Can we go using pen and paper just in case? Sure. I think just in case. Yeah. It does look like. Let's look at right. Oh, but I don't know. But no, can't bother that. Don't risk it. How do you make this thing? Happy to try.
Okay, so hopefully you've had a chance to give it a try. So let's go through what this looks like. This is my first time using this, so getting used to it. So we start off with an empty list. And then we append 1, and then 3, and then 9. Okay, so that's the first 4 lines. And then we change this value here, so 0 to a dog. Okay, so I'm just going to write dog. And then we add 27 as that 5th or 6th line there. Okay. And then list 1 plus equals list 2. So can anyone explain what that means? Yeah. Yeah. Perfect. Exactly. So list 1. So again, we can break this down to list 1 equals list 1 plus list 2. So list 1 in this case is 3. List 2 in this case is 9. And so this value here will change to 12. Okay. And then list pop -2. So recall this is -1 here, -2. We get rid of this one. Does that make sense? So we popped out the value. And then list -1, which is this value here, is now equal to 6. So what that ends up with is we have dog 12, 6. Any questions? Okay. Yeah.
For the list, if you put this 37, 37 is an integer, right? You can just add it inside the list. I thought the part is like 39. You can only add like another list into it. You can use.
You can add in, yeah, you can add in those numbers direct. Okay. It just simply appends it in this case to the end of the value, but if it's a list, then we'll extend it. Okay. Great question. Okay, awesome. So let's move on. All right, so try your hand at this one. So this is a really good note as well, but note how I'm using the words LST as our variable, and I'm not using LIST. The reason behind that is because LIST, so this is actually a protected term. So you can't use it as a variable. So if you try and use that as a variable, it's going to lead to really bizarre errors.
Yeah, yeah, I know, right? Yeah.
Yeah, I know.
What's the Queen Square Route? From there. So I have to add them. I've been serious and stuff. It was like straight.
I got one.
No, no, actually, I haven't seen that one. That'll play the rest of
I get one.
The same thing. Technically, going negative 1 0, it's going to. Then do you replace one with one? But it's still 0 at the start.
One. Yeah, where did I get my one?
No, you got your 1. 0 to 1. Because the list of the 1, so then you get to these parts of 0 to 5, right?
Yeah,
So then, and then negative 4 is at 1, because if we're going that way, it's sort of. There's nothing I have to change that. Yeah, I still think. It's gonna be negative 1. Yeah, no. Yeah, you're right. Yeah. Like, one thing, I'm thinking.
Yeah, it's just like a way to think about last time the parking lot. Parking lot, yeah.
Yeah, and then like, next. No, I went pretty. Yeah.
All right, so let's run through it. Okay, so we start with 1. Oop, whoa. There we go. 2, 0. Okay, so this is our starting list here. So the first is we change this second item here to a list, right? Which is our list. So we get 1, 2, and then 1, 2, 0, like that. Okay, so we have a compound list. Okay, so any questions with that step in particular? No? All right, and then in the third step, we go list plus equals list 2. So in this case here, we go 0, so this is 1, this is 2. We add this again. All right. Oh, yes, you're right. Actually, it extends it. My bad, my bad. It fell to my own trap. All right. All right. Okay. And then the next question is if len list 2 equals 2. Okay, so this in this case is 0, 1, 2. So if len list 2 equals to 2. So is this true or false? False, perfect. So we then change this to a kangaroo, okay? And then list reverse does what it sounds like, which is it completely reverts the list, okay? So in this case, it will be 0, 2, 1, 1, 2, 0. So keep in mind that it reverts the outer list, but not the inside list, okay? So that still retains its function there, or its order. Then 2, then kangaroo. Okay, any questions so far? And then list equals -4, 0. So in this case, this is -1, -2, -3, -4, -5, and then -6. Okay, so -4 means that we include -4. So we basically cut it here. So it starts here and then it ends all the way here. Okay, so what we're doing to this list is we're getting rid of these two values in particular. Does that make sense? Okay, and then list plus equals len list. So what is the length of the list in this case? 4. Perfect. Okay, so the final product is 1. So we just copy here. 1, 2, 0, 2, kangaroo, and then 4. Any questions? Yeah.
If this second was 1, then we -4 colon 0.
Yeah. -4 colon 0. Yes, it'll be the same thing. Yeah. So if at the end, particularly for a negative thing, it just goes all the way to the end, right? Which in this case would be 0. Yeah. Yeah. Okay. Perfect. All right. So this is a trickier one. You're never going to get anything like this in real life, but it does teach you how lists work. Okay. All right. So let's move on to the next section. Okay. So when you're dealing with loops, it is what's called an iterable in Python, meaning that you can for loop over it. Okay, so Python has a class of objects. So objects just meaning anything that with a type, right? It has a class of objects that you can iterate over. So let me just change this. It's less distracting. Oh, sorry. This one. There we go. Okay. So this are an iterable object, meaning that you can for loop over it and Python understands what exactly is happening. Okay. So for example, say we have list equals 1, 2, 3 here. One way to do a for loop over a list is what's called a for each index loop, meaning that you actually define the index in the for loop like this. Okay, so for example, for I in range, in this you have to define the length of the list. Okay, so say in this case, the length of the list is 3. It will basically evaluate to for I in range 3. Okay, and then you can modify or do something with that index. Okay, so a very useful use for this for each index loop is to actually modify different values in the list. Okay, so it iterates over the index and it's very useful to modify elements. So it iterates over each index of the list. Now, a different type of loop you can do with a for loop is called a for each element loop. Okay, so what that means is say we have list equals 1, 2, 3. Instead of defining an index that you loop over, you basically go for each element in the list. Okay, meaning that you can actually use and pull out 1, 2, 3, 4. Okay, so those are just two different ways of doing a for loop for a list. So in this way, you basically refer to the index and then you do something with that index value. Okay, well, this one here, you refer to the specific value. So you're just pulling the value out and you're not referring to the index. So when would that be, or when would that be useful versus this? So this would be useful when you're actually modifying values inside a list, because remember, to modify a value in the list, you actually need to refer to the index. Okay, so remember, it's like list 0 equals something. You need to modify the index. Okay, you need to refer to the index. And for something like this, it is a much simpler way to write a for loop. So it's much easier to read. So take a look at that versus this. It's much easier to read if you're basically just pulling out the value and doing something with it, but not changing anything inside the list. Does that make sense? Okay, so this is, again, a useful paradigm to be aware of. You will see different types of code that use different types of for loops, right, on the list. And it actually tells you, as someone who's reading this code, oh, like if someone's using this, they're likely modifying the list. So it's an active list that's actively changing, okay, dynamically changing. What if you see this? It's a passive list. It's a list that you simply just pull information out of and you never update or you never change. Yeah.
So in this case, the list stays the same, but you can change within the for loop the item that you pull out.
You can do whatever you'd like.
Done to it,
Yeah.
it doesn't change the.
Exactly. You'll never change the list because in this case, you can't change the list because you're pulling out the element directly. Okay, but in this case here, you're pulling out you're using an index, meaning that you're probably modifying something in the list. Okay, so it's just one of those little code things that you see your code and you go, okay, someone's actually actively changing this list versus they're actually simply using a value from the list. Okay, and it's good practice again to stick to this. If, for example, you're doing research and you simply want to pull values out, then please use this for loop because it indicates to everyone else that you're not actually actively changing the list. Okay, but if, for example, you're directly modifying, then you do want to use the for in because it indicates to everyone that this is a dynamic list and they have to be careful, right? Because you might be changing it later down. Okay. All right. Now, James talked about this briefly yesterday, but it's something that's very important today, and we'll go through some examples, which is you have objects in Python that are immutable and mutable. And what on earth does that mean? So immutable means that if you have something in a function and you change that value in the function, right, these changes are only temporary. Okay, so for example, if you pass x equals 3 into a function and then you increment it to 4 and then you exit out of the function, Python just throws away the 4. Does that make sense? Okay, and that applies to all basic data types. So for example, if you have an integer, a float, or a string, and you pass it to a function, and we'll go through an example very shortly, right? You pass it to a function, you modify it within the function, the global variable will never change. Okay, you just basically throw it out unless you return it and then you save it. So this is what's called pass by value, because you're simply passing the value of the object. Okay, so say x equals 3, you're simply passing a 3 to the function. Okay. Now, when we're dealing with data structures, so for example, lists and dicts or dictionaries, these changes are actually permanent. Okay. So what Python does, what's called passing by reference, which it tells the function, I'm referring to this list, and if you make any changes, it's going to be permanent. Okay. So for example, if you add a 1 to the end of the list inside a function, and you go outside the function, the 1 is still there. Okay. So let's go through an example and see what that looks like. So say we have this function here. So recall Python looks at this. It goes, all right, I remember this function here, add 3, fine. Num equals 1. And then add 3, num. So we pass this number 1 value here into the function add 3. And then it calls add 3. So 1 appears here. Okay. Num equals num plus 3. So what will num equal to in this case? 4, perfect. Okay, cool. And then if we try and print num outside of the function, what will print? 1, exactly. So what Python's doing is it's simply passing the value. It's passing the 1, right? And then the function uses the 1, and then it throws it away. Okay, and then it prints. Once it prints out the 1. Okay. Now say we have this instead. So this is the exact same program, except I'm using a list instead. Okay. So we have values equals 1, 2. We pass values to the function. The function accepts values. So values, in this case, in the top, define add 3. This will become 1, 2. And then we append the number 3 at the end. Okay, so it becomes 1, 2, 3 inside the function. Now, if we exit and we try to print values, what's going to happen? 1, 2, 3. Exactly. So the list, any changes that you make inside a function, it becomes permanent. Okay. And this applies to any complex data type. So dictionaries, tuples, lists, but it doesn't apply to the basic types. Okay. So if it's an integer or float, it does not apply. So when Python sees a data structure, it passes by reference, which is sort of like a URL. Okay. So instead of passing the actual value of it, because it's such a complex structure, it passes a reference to it, so a link to it. Right, and any changes that the function makes to that link is reflected permanently. Okay, so in computer science speak, we call this as list immutable. Mutable meaning that it can be changed inside a function permanently. Okay, so whatever changes you make inside a function, you have to be careful because once you exit out of that function, it's permanent. Okay, it stays there forever. All right. So this is another sort of caveat to this, but say we have the exact same function, and then we go values equals 1, 2, we pass values to this list, right, to this function here. We append 3, right? But then we say list equals 4, 5. So what prints now? Yeah. No, so it actually prints 1, 2, 3. And the reason for that is that when you do something like this, the function actually creates a different list. It creates a second copy of list. Okay? And that second copy has no bearing whatsoever on this list here. Okay? So it's a bit of a quirk. If you change this list, so you pass the list and you change it, it's permanent. And then if you decide to create a new list, this is a completely different variable in a different namespace. Okay? So what will print will be 1, 2, 3. Okay, so 4, 5 is a new list and it's completely thrown away. Okay, so that's sort of passing by reference and value sort of all together at the same time. But just keep in mind that if you modify a list, it's permanent. If you decide to create a new list, it just ignores it. Okay? So this is where it gets a little bit tricky in Python. So just make sure that you understand this thing. The list would not exist outside of the function. Yeah, yeah. So it exists only in that code. Okay? Yeah. if you redefine values for five, is that apply universally as well? Values, values are do this. If it's inside the function, it doesn't, yeah, it doesn't exist. No, it's a different it doesn't understand what values is because you never define values in the function. Right. So remember that the only way, and this is something that you sort of need to keep in your mind, right? When you're dealing with different variables, right? They exist in a specific space, right? So the only way to communicate, so for example, if you have values here, right, it exists in the global space here, but it doesn't exist in here, right? It has its own space, right? So remember the sort of housing structure that James was showing yesterday, right? The only way to communicate with functions is to pass it parameters using this and to return parameters to get information out. Okay, so there's only one way in and one way out. Okay, and it's through those two means. Okay, now this theoretically is one other way out, right? Which is if you modify a data structure, then you can actually pull data out of that function. Okay, so beyond return with data structures, you can actually modify something inside and then it will become permanent. Right, but in this case, what we're doing is we're creating a completely different thing here. Python sees this as very different to this. Okay, because it sees it as values. Okay, so it stores it in a different type memory place. And then this creates a completely new sort of room here, and then it throws it out as soon as the function ends. Okay, so this is very tricky, yeah.
What if you reverse all of in after creating this? Is it depend on the 4-5 or depend on the
That's a great question. So does anyone know what happens if, for example, we write this up here instead? So remember that this function here creates, so we have values, which is located here, and then we create a new list here, 4, 5, right? Now what happens if we append 3 to this list here? So it would become 4, 5, 3, and then it throws it away, and it keeps this values here. Does that make sense? Yeah, so the 3, if you try and put that, will become 1, 2, because the 3 was never appended to the original one. Okay, very tricky stuff. Cool. All right, now this, and we're getting to the end of this, lists can become 2D lists as well. Okay, so this is now where we're starting to deal with math, and we have a 2x2 matrix, for example, right? And so this is actually a 2x2 matrix, where you have an outer list, and then an inner list inside. So it's like 1, 2, comma, 3, 4. And so one way we can mathematically represent it is actually 1, 2, 3, 4. Okay, so that's a very sort of natural way to do it. Now, how do you index? If, for example, you list 0, then you get back this object here. Okay. Now, if you want to double index, then you go this 0, 0. Okay, and if you add that second one, it'll go, okay, I'll grab this object. Now, this is my list 0. I'm going to 0 index that as well, which is 1. Does that make sense? Okay, so what would list 1, 0 be? Sorry? 3, okay, so let's think about it. So this 1 means that we grab this object here, and the 0 index of this list is 3. Does that make sense? Now, what if we do this? So this 0, 1 equals 7. What value will change? The 2. Yeah, the 2 will become 7. Exactly. Okay. All right. Now, say we have this 2x2 matrix. So we see there's a 2x2 matrix now. How would we get the number of rows and columns? Yeah.
Number of rows.
Length of the first list, exactly. So the length of the first list, let me just quickly explain that. But if you length the first list, so there's one item here, and then a second item here. And if we think about what that corresponds to, 1, 2 is the row, and then a second row. Okay, so that's how you would get rows. What about columns?
Thank you.
Yes, exactly. So let me go through that again. So length of this 0. So this 0 is this, right? And if we do the length of that, 1 and 2, again be 2, but we've now calculated the columns. Does that make sense? So that's how you get rows and columns. Okay, so length of the first list and length of this 0. Now, with columns, would length of list 1 work as well? Yeah. Yes, okay, because you're simply getting the second 3, 4 there, And calculating the length of that, that's just another way to count columns. Okay. All right, so to-do lists are very powerful when it comes to dealing with, so double for loops are very powerful when it comes to dealing with to-do lists, right? So for example, in this case, if we have list equals 1, 2, 3, 4 for I in range and then rows, and then columns for J in range columns, if we print this IJ, then it'll print out 1, 2, 3, 4. Okay, so that's one way to enumerate a whole list. Okay, so just print out all the values of the list in from left to right, top to bottom. Okay, and we just basically put in our formulas from before. So this is a very effective way to basically print out or do something with that list. Okay, so for example, if you have a 2D array of something, then you can add 1 to everything, right? You can simply sort of increment every value, for example, right? Now, this is very useful when it comes to images, because how images are stored in computer science is it's basically just a 2D array of values, where the value goes from 0 to 100 to 225 or 255, where 0 equals black and 255 equals white. Okay? Yeah.
No.
Awesome. So if you take a look there closely, it's just a matrix of numbers. Okay. Now that's grayscale images. When it comes to colored images, you have a 3D matrix. Okay, which also goes from 0, in this case 0 to 1, but usually it's 0 to 255, right? Where 0 again indicates white, and 255, for example, with red indicates full red, full green, full blue. Okay, you can actually get any color you want based on just those 3 values. Okay. Now, just before we move on as well, does anyone have any ideas what videos look like? Yeah. Yeah, so there's actually just a 4th dimension, which is time. Okay, so it's just RGB. So that's obviously one still image. But then once you're dealing with the video, for example, there's a 4th dimension, which is time. Okay, so for example, you're dealing with CT data, MRI data, it depends on how you're looking, right? CT and MRI is usually 3D, right? Because we're dealing with voxels. But if, for example, it's a dynamic MRI or something with time embedded, then there's just simply a 4th dimension, which is time. Okay. All right. Now the list has a lot of different methods, and we won't go through each one, but you can always search list methods and actually just read how it works, right? There's lots of really cool things you can do. So we obviously introduced you to reverse, which just simply reverses the order of the list. But then there's also things like sort, right? And we'll talk a little bit more later about how to sort things. You can, for example, remove items instead of pop items, right? What's the difference? Pop is a faster operation, so it's an O1 operation, so it's a bit much shorter time complexity. While remove can take a little bit longer. You can insert, you can index, you can extend the list. As we said, we can count the number of things in the list. You can copy the list, clear it, so you can remove everything in a list, and then you can also append. So those are just the different methods of the list. Okay. All right, and then we'll go through this as well, and James went through this yesterday, but basically every list, it explains the method. So it actually explains what it does. It explains the different parameters you can use inside the brackets, right, to dictate behavior. And it just explains what the parameters are and whether it's required, whether it's not required, whether it's optional, what it actually does. Okay. All right, now time complexity, and we'll go through some more examples of this later in the day. The time complexity for lists is pretty quick. So remember, this is an optimized piece of code in Python. So if you want to append something, you want to index something, you want to get the length, it's all O1 operations, meaning that it operates in a single operation. Okay, it's very, very fast. And what does a single operation mean? It depends on your CPU or GPU. It's just one cycle of the CPU or GPU. Okay, and if anyone's ever seen GPUs, it's like 4.8 gigahertz or something, right? That usually is the frequency in which a clock actually works down at the GPU level. So it's 1 second divided by 4.7 times 10 to the power 9. So it's very, very fast. Well, we're talking nanoseconds at this stage, right? And then copy is ON. So N meaning the length of your list. Okay. All right. Now there's some really cool stuff that you can do in Python here, which is list comprehensions. So say we have lists of fruits. So apple, banana, cherry, kiwi, mango. This is a list of strings. and we want to create a new list with only fruits that have an A in it. So I want you to spend some time just seeing what that actually looks like. It should just be a few lines of code. But see if you can write code that actually can do this. So you can just use Colab. Today we'll be sort of using Colab. So just open that up and just write code. So another thing to think about is what type of for loop do you want? Do you want to use a for each index one or for each element one? Are you changing something in the list or just simply drawing information out of the list? Well, we like
Yeah. Accidentally. You think the same name. One to I think. Yes. Oh, why not? I Oh, wait. Yeah.
So that'll be like one of the.
I think that's.
Is it this one that was I? Yeah, right. Well, yeah, it needs to be communicated to the garage.
Because this is also exists.
Yeah, the one for the garage. Great.
So what I was just saying, I think about
Yo. The pay, have pay. Has to be paid. Like alligator pay.
Yeah, so the first question is actually, so it says to create a new list, so you have one of my, we actually use a.
Anyway, that's not as paid.
Yeah, we should make sure.
Yeah.
We'll see, another way is to say.
I think it's not paid.
It's a French, you say. Say,
Right. Yeah.
You name it. Yeah.
so. So,
Yeah.
more elements.
And I want to.
The second time, elements of that, or I saw time to improve all that. Time to want to do that, but when I tell to sit down and just finish it. Yeah.
That's nice thought, right? Very.
Yeah.
I guess I can. No.
Yeah, so again, do you prefer using image text or? So, so the two ways that image. So you have.
But that sounds like we.
This one here. Because it's just a creating race. You don't want.
Yeah, in my one, I didn't made like.
Yeah, it gets really complicated. See how that.
Yeah.
So it's.
Look at the.
Yeah, so you can start with the strengths and you can also appreciate that and see if there's anything to new ways to see. So that's basic.
I'm very good. So,
Oh, because this will be pretty helpful, like a in app.
Oh, okay, sure.
Yeah.
Like that, you mean?
Yeah, exactly.
okay,
But
yeah,
people
okay.
didn't know.
Okay,
if
sure.
that method
Yeah,
exists,
yeah, okay. Okay.
You want to
Just, yeah, I'll just say that.
Okay.
Yeah, real quick. Yeah, if you can change that. So I'll just show you guys a very quick way of looking for a specific letter in a word. So this is, if you read through string methods, you'll find this. But say you have string equals mango, okay? If a in string is actually a legitimate Boolean. Okay, so Python is very sort of straightforward and it says, so it should be that. If a in mango, this will evaluate to true. Okay. So that's a neat little trick. And then just another, see if I can write here. So maybe just to explain the for each LM thing again. So you have two ways of doing for loops when it comes to lists. The first is for each index. So for I in range len list. Right. So for example, if you go print fruits, I, then we'll print each individual fruit, right? Now you want to use this if you want to intend to modify the list. So for this task, if you take a look, we asked to create a new list, meaning that you shouldn't modify the old list, okay? And the reason for that is this gets really messy later on when you need to deal with indexing in your function, okay? The second way, an easier way, which would be recommended, is for lm in, so in this case, sorry, it should be fruits. For lm in fruits, print lm. This will lead to the exact same result where you print out each fruit individually as well. So every time they iterate through it, it will, for example, assign lm to apple or to banana, okay? Every single time. So try this and then see the behavior of it. But this would be best if you don't intend to change the list, which is what we're trying to do today, okay? So try and use this method here.
okay, so I think
But I do not need to be able to. It's very strange with it. Oh, this is facts, but it's not that.
Yeah.
Can you?
Yeah, so it's like,
I especially with the other. You want to take different parts. Or just be a trying to get different parts. Trains with zero. Yeah.
it's like the side.
Yeah. Yeah. So I can do like this and then repeat it.
Yeah.
Jason theory.
Yeah, well, again, it's like,
Like start train.
yeah. So for example, it could be like one of the first thing. Yeah, I mean, you wouldn't use it, right? Well, if it's saying it's a full instance, then if you're like, if you're not in university, then.
Yeah, yeah. I think that's.
Yeah, so this guy's.
Yeah, exactly. That's why, yeah, there's a mutable system, so changes you make actually change. That's why it depends on like. That's what the conversation we have to, we have to equal itself, when these change is already made for that we change.
Yeah.
It's not allowed, but yeah, that's necessarily.
Yeah. So somehow it's having just. Yeah, yeah. Alright, cool. So let's go through an example, or let's go through what this looks like. So this is all the code you need. So it's just a couple of lines. So because we're creating a new list, so let me just switch this. So because we're creating a new list, we want to just create a new list, and new fruits equals empty list. And then for fruit in fruit. So in this case, I just use the word fruit in fruits. So instead of LM, right? If A is in fruit, then we append that fruit to new fruits. Okay, any questions? All right, so Python actually allows you to do this in a single line, which is a very cool thing called a list comprehension. Okay, and it looks like this. So new fruits, so you create the list, equals fruit, for fruit in fruits, if A in fruits. So give that a try. So actually put that into your line of code and see if it spits out the exact same thing. So if, for example, you're using LM and you want to use LM, then it'll be LM for LM in fruits. Okay, so just replace the word fruits with a not with a singular fruit with LM.
Oh, did you define fruits?
Oh.
The last fruit, I don't think this egg is inside the fruit.
Oh, sorry. So I've got a typo in there. Actually, the last fruits should not have an S. Okay, because it's for if A in fruit. So that S accidentally. So try that without the fruits plural. Yeah. Cool. So let's go through what this example is. Yeah. All right, so this is it's somewhat confusing piece of code, so let's break it down, right? Because you might see this out in the wild. And so how it works is we basically have broken this down into different components here. So I've just color coded it just for simplicity. But we have new fruits equals 2, and then we have the list here. And then what comes inside that is we say we want to append this first for fruit in fruits if A in fruit. Does that make sense? So it is something confusing. It is something that, you know, it might be a bit overkill, but it is something that you might also see in active code. Okay, because particularly for software engineers who do this a lot, they just simply see a list comprehension immediately. Okay, so there's something useful to just be aware of, but it is a very cool Python thing that exists. All right, so let's move on. Now, I think we might be running out of time, so we're going to leave these exercises for later if you'd like to do them, just because we need to go through dictionaries as well before the break. Also strings. So let's first go through strings. So we've been dealing with strings now for quite some days, and the sort of primary way that we've been dealing with strings is twofold. One is through the input function. So remember, you can ask the user for input and then it returns a string, or you can define a string yourself. Now, there's a couple of reasons why strings allow you to use both the single apostrophe and the double apostrophe marks, right? And the primary reason is, we'll go through it in a little bit, but if you want to go through an example here, so see how if you have a single apostrophe, it allows you to define double apostrophe inside the string itself, okay? And you can also use it vice versa. So if you have a double apostrophe, you can make the single apostrophe as part of the strings, okay? Now to create an empty string, you can create, similarly to a list, just an empty string with either a single or double apostrophe at the end. Now you can't mix and match single and double apostrophe. So if, for example, you start with a single apostrophe, you can't end with a double apostrophe. Okay, so Python reads that. Now, if we have this, for example, what sort of error might come up? Any ideas? No? So what actually happens instead is it reads this first apostrophe as the start of a string. Okay? And then it reads this as part of the string. And then this first one here, it reads as the end of the string. And then this, there's an aberrant string there. Okay, or there's an aberrant apostrophe there. And it doesn't understand what exactly is happening. So does anyone know how to get out of this situation in particular? Yeah. Yeah, so yeah, both answers are acceptable. So you can replace the outside brackets with double apostrophe. So that's a very obvious solution. Or you can use this special character called an escape character. Okay, and this escape character basically tells Python that whatever the next character is treated as part of the string. Okay, so in this case, Python will read this first apostrophe here as the start of a string,
this as part of the string. This as part of the string because of this escape character. So this doesn't appear in your string. Okay, so Python completely ignores it, right? If you want to use this as part of your string, then you add a second escape character. Does that make sense? So you add that, and then Python's like, okay, the next thing is not some special thing, it's just part of the string. And then this last one ends the string. Does that make sense? So this is a very special type of string that allows you to sort of get around some of the tricks of strings. Now, when we look at a string, it actually is just an array of characters. Now, do we have any data structures that we can use to model strings? Yeah. So the most similar thing is a list, but there are some fundamental important differences which we'll go through, okay? One of which is that it is immutable, so it is a basic data type. So for example, if you modify a string inside a function, it is impermanent. It's temporary, it gets thrown away. Okay, but for a list, if you modify it inside a function, then it's permanent and it goes outside of the function. Okay? So strings operate very similarly to lists, right? And there are also indexing as well. Okay, so 0, it starts from 0 and it goes up. Okay, and if you take a look at this, I've added a 5 for this empty space here. This is also a special character in a string. Okay, if you, for example, don't have that space, then it just simply says hello world without that space. Okay, the exclamation mark is also a special character as well. Now, indexing works very similarly. So if we have string equals hello, and notice how I use str, not the word string. The word string itself is a protected term similar to this. So if you start using the word string in your code as a variable, it's going to break the system, okay? So string equals hello, what would str0 equal in this case? Yeah, the character h. So it returns another string, which is just simply the character h. Okay? What about string 1? E, right? Perfect. So it just returns another string just with the letter E, so a single character. It will have the apostrophes. Yeah. Okay. Now, Python also allows you to index very similarly to lists. So what would string -1 be in this case? Yeah. Exclamation mark. Okay, so it goes back from the end of the word and goes back 1. Now, what about 0 to 2? Yeah.
E.
P, exactly. Okay, so remember, the first value, it is included. The second value is not included. So it only goes 0, 1, which is H and E. Okay, so it returns a string, which is H and E. What about 3 and then the colon? No, exactly. So it includes 3, LO, and then it goes to the end of the string, which is exclamation mark. Now, what if we do len string? 6, exactly. So this has 6 characters, so the length of the string is 6. Okay. All right, now when we're dealing with for loops of strings, there are exactly 2 ways, just similarly to lists. So you can do a for each index way. So that is if you, for example, intend to modify the string in some way. Now we actually aren't allowed to modify the string in this way, which we'll go through later. But you can, for example, for index in range len string, print string I, and it will print exactly that. Okay. You can also do, and this I prefer because it's a lot simpler, which is you simply say for character in string, then print the character. And similarly to how you were printing each individual fruit, it just prints each individual letter. Okay. All right, concatenation is somewhat similar to this, right? But there's none of that append extend nonsense. You just simply add things. Okay, so for example, if you have string 1 equals ABC, string 2 equals DEF, and string 3 equals string 1 plus string 2, then can anyone guess what string 3 equals? ABC, yeah, exactly. Okay, so it works very simply. All right, now string has a lot of interesting methods. So string itself is a very special data structure that allows you to do very cool different things. So string split is this special method here. So say we have a message. This is not a drill. Okay. Split message. If you split this message, then it actually returns a list, right? With each individual word as a component of that list. Okay. The list components are strings themselves.
And the default behavior of the split is to break based on spaces, so white spaces. Okay. Now you can also split based on something else. So for example, if you have, I don't know, like research data and it's comma separated, you can use message split and specify a comma, and then we'll split it based on the comma. Okay. Now you can also find items in it. Okay, so string find item returns the index of the first occurrence of that substring. Okay, and it returns -1 if you can't find it. So for example, if we have message, this is not a drill, what would be the index that message find returns for the first one?
Five.
Yeah, so that's a great question. So the first is, what index does it return? It returns the very first index of the first letter. Okay. Now, is the answer 5 then?
Be the is in the B.
Yeah, exactly. There's actually the word is in this. Right, so in this case, this actually goes, okay, so the first is I see is this one here. Right, 0, 1, 2, and we'll return the number 2. Okay, now what if I try to find while? -1, okay, there's just no while in that, so it returns a -1. Now strings have lots of different methods, okay, we're not going to go through each one, but there's some really cool methods that are available. So for example, and I think we'll go through some, but there's ones that check if, for example, you have an alphabet letter, or you have something that's non-alphabet, or you have something that's a number or not a number, right? You can capitalize things, lowercase things, you can change spaces to commas, you can do whatever you'd like with strings, okay? So make sure to open up, because I think you need this. So search string methods, and you can go on W3 or the Python docs if you want, right? But there's lots of different string methods because you need to refer to some of them. So work with your team or work with your partner to build a predicate function. So recall predicate function returns true or false, right? Depending on whether it's true or false. Is predicate that accepts a lowercase string and returns true if the input is a palindrome. Okay, and the challenge is, if you manage to do it very easily, then can you make it work with palindromic sentences with any case?
Next is All right. For a remote. Yeah. Sorry. It means that my life is going to be every day. I want. That can make the leap. Like we know.
Sorry?
It's getting pretty hard.
Yeah, yeah, some of these are gonna be hard.
Basically.
Yeah, it's fun. I mean, this one is doable. You know how to do it in a single one?
Yeah, just like comma, like colon,
Yeah, exactly, yeah.
yeah. So many ways to do it. It's really cool.
Yeah, that's very cool.
Yeah.
Yeah, yeah, that's what I do.
Carefully on types.
Yeah. Yeah, that's. I think there's that.
That, so that.
Yeah.
Yeah, thanks. I think. Oh, man, I don't know. Great.
Oh. I see what you're saying.
Yeah. Actually, yeah, I can buy it. Yeah, actually, yeah. This is. Yeah. Like, I don't really have coding, I think I really have a mind every. Oh, wait. Oh, you can make a list of the punctuation, and then you have four element, punctuation mark in punctuation. String replace. Either way. Well, that's for the base. I tried to look at the string that well, yeah. But it's just weird. No, I just don't, it doesn't seem. But yeah, I think you can. Theoretically. No, no, no. Yeah, like,
Oh, is that?
Yeah, yeah.
There's a thing you can do.
Yeah. So the legal disciplines.
Right.
So you can go into really the weeds of this. All of this I represent like, so think about. What do you remember when that big numbers, so like say it's 1, 2, what is the one? Start, right? How would you want us?
Yeah, well, yeah.
Yeah. Yes.
Let's just do it.
Yeah, I don't know. Yeah, we should check.
All right, everyone. So we're going to go through the answer to the first one.
So, if you recall from indexing, right? There is actually a way to step backwards from a string. So some of you were trying to use string.reverse, which is actually not a method, unfortunately, right? It exists for lists, but it doesn't exist for strings. And how we actually reverse a string is using indexing. Okay, so recall that we had, for example, 1, 2, 3. 1 would indicate the start, 2 would indicate the end or the stop. And then the third one is actually the step size. And the step size, we can actually step backwards as well. Okay, so this is a very elegant one-line solution to checking if a string is a palindrome. Okay, so for example, if we take a look at the word race car, we have 0, 1, 2, 3, 4, 5, 6, and then the reverse version, which is string : : -1. Reverses it, we get 6, 5, 4, 3, 2, 1, 0, and it just checks if race car equals race car. Does that make sense? If, for example, we have race cat, when we reverse it, we're going to get tacky car, and it just checks if race car is equal to tacky car, which it's not. Okay. All right. Now let's go through some strings, and this is again just can you use some of the methods that you see in the strings. So some of the techniques that we need to do for this one is we need to remove punctuation, we need to remove white spaces, so anything that's a space, and we also need to lowercase everything. Okay, so there's lots of different ways to do it. I saw people were using all sorts of types of functions for this, for example, like case fold, right? But this is one way to do it. So, for example, you can use lower, which lowercases everything. Okay, so it's another version of case fold. You can also use is alpha to screen out anything that's not an alphabet. Okay. So this is how I did it. There's again lots of different ways to do it, right? And you might have your own absolute way, but I break it down into 4 different steps. So the first is to make a new string, which is a clean string. The second step is to lowercase everything. The third step is to remove anything that's non-alphabetic, so anything that's punctuation or white spaces, and then we check if it's a palindrome using the exact same technique we had before. Okay. So one really important thing that you might have realized is because strings are a basic type and they're immutable, they cannot be changed in place. Okay, so for example, if I have this string here, unlike a list, you can't index a letter and then change it. Does that make sense? So you can't go string 0 equals Z, and you can't change the W to a Z. Okay, so strings are immutable, they cannot be changed in place. Okay. So because of that, when you're working with strings, you always want to create a new string before doing anything else. Okay? Always create a new string. And so we create a new string here. And then we lowercase everything. So we just go string equals string.lower. Okay? So that lowercases everything. If you take a look at the was it a car or cat I saw, it lowercases everything. Right? And then we remove the non-alphabet. And how we do that is we go for each character in the string. If the character is an alphabet, then we add it to our clean string. Does that make sense? I'll just go through it again. So for each character in the string, if the character is part of the alphabet, then we add it to our clean string. Okay? And then that's basically what happens at that stage for clean string. So it just looks like was it a car or a cat I saw, but without any punctuation, without any white spaces. And then we check if it's a palindrome. Does that make sense? Okay. Now there's faster ways to do this as well. So for example, instead of lowercasing everything as a first step, we can actually lowercase it as we add the character to the string. Okay, so it's a slightly neater and faster way of doing it. Because in this case, we do it in a single step. All right, now let's go through what characters look like and mean. So we covered this yesterday, but every character is actually assigned to a specific ASCII or Unicode code. Okay, so all it is in the CPU or GPU, generally the CPU, there's actually a giant lookup table that just simply says, if you see this character here, so for example, this English A, right? Then in the CPU, it actually converts it to a specific number, which is 65 in this case. Okay, so the CPU will see the letter A as 65. And if you think about it, that makes sense because if you have characters from multiple different languages, right? How do you encode it in the CPU? Okay, if it's just English, maybe it's somewhat straightforward. But again, you have Chinese characters, Japanese characters, whatever characters you want. They have very specific codes. And so if you take a look at the ASCII table, there's obviously a bunch of special stuff just for the computer. So for example, if you do a backspace, right? then the computer sees that as the number 8, okay? And then it has punctuation, and then 0 to 9 is continuous. Followed by a bunch of other punctuation, and then capital letter A to Z, and then lowercase a to Z. Okay, so those are continuous. So for example, if you know that capital A is 65, you're going to know that capital B is 66. Okay, so those are sort of ways to do it. In order to get the ASCII value from a character, you can use this function called ORD. Okay, so Python allows you to ORD, which we used yesterday. And then if you add, for example, A in a string, then it will return 65. Now this actually allows words to be represented as numbers, which means that you can use inequalities and compare strings. Okay, so for example, if you say string equals ABC, and if you ask if string is equal to ABC, this will be true. Does that make sense? So it does check using the ASCII codes. Now you can also do comparisons. So for example, if you have the word aardvark, it actually compares it letter by letter, almost alphabetically, okay? Almost, and I say almost because there are some important differences. So aardvark is the letter A is before the letter K in the ASCII table, and therefore this will be smaller than this. Does that make sense? Okay, this, I don't know exactly what the numbers are, but that might be like 97, and that could be like 105, or whatever it is, okay? Now, we call this lexicographic order and not alphabetic order because there are some very bizarre things that can happen. So this is another example here. Z is after K, so Z would not be smaller than K. So this would be false, okay? Now case matters because if you saw in the ASCII table, capital letters happen before lowercase letters, right? In that table. Because of that, ABC is smaller, uppercase ABC is smaller than lowercase ABC. Does that make sense? Because it's relying on that ASCII table. The word zebra with the capital Z or Z is smaller than aardvark with a lowercase a. Because capital letters go before lowercase letters in the ASCII table. Does that make sense? Okay, so just be very careful, particularly the case when you're dealing with strings and string comparisons. Now, as a basic type, like I said before, strings are completely immutable. So you are not allowed to change strings in place. So for example, if you have string 1 equals ABC, and then you say string 1 0 equals Z, that is the error you can throw. Okay, so it's just going to say that string object does not support item assignment. Okay, you cannot assign different items inside the string. If you want to work with strings and create a new string, then you actually just say string 2 equals AZZ. So you create a completely new string, and Python's very happy. So we've gone through this before, but let's take a look at this, what this actually looks like. So if we have values A, B, and then we add A values, then it actually adds a C. This list will permanently change to have A, B, and C. Okay, so hopefully this is just revision from this morning. Recall this is passing by reference. Okay, so if we refer to passing by reference, it means that whatever we pass permanently changes. Now, because strings are a basic type and they are immutable, if we try and do the same thing to a string, then it passes by value. Okay, whatever change we make inside the function is only temporary. Okay, so strings act very much like numbers or floats. Okay, so this is one of the main differences between lists and strings. So just have to be something careful with, because sometimes people see strings, they get excited about indexing, they don't realize that strings actually act very differently to lists in some circumstances. Okay. All right, printing strings. So this is now just back to some basic functions. If you want to print a string, we've done this before, just simply print it. Now, when you're trying to print strings, note that you have to introduce white spaces. Okay, so you have to tell the computer that you actually want a white space. Okay, so if, for example, I want to write hello Clark, I actually have to have a white space in either greeting at the end of hello or white space before my name in name. Okay. If, for example, I get rid of the white space, then it doesn't have a white space in what it actually prints. Does that make sense? All right, now this is a special character called a new line. So when you have an escape character followed by an N, that actually doesn't act as an escape character. And it basically tells Python to introduce a new line. Okay, so previously I had this, right, hello far, then I add in the \n, and it far goes down to a new line. Does that make sense? Okay, so that's how you indicate to Python that you want a new line using that special red character that. Now you can also do it if you have two different print functions. Okay, so if, for example, you do print hello and then print far, it will automatically have a new line. Okay, but keep in mind the difference is that this is a single string, while this is two strings that it prints. All right, now we've done this before, but if, for example, just a reminder, if you try and print both a string and an int together, Python doesn't like it, right? And so you have to convert it to a string first. Now we've covered F strings before, and hopefully this is familiar. But if, for example, you put the letter F in front of the print at the start of the print function, then it accepts num as a variable using the curly braces. All right, so see if you can work, and unfortunately you don't have to write anything in this one, but see if you can work with your table to explain what is happening in this code. Okay, so I'll give you about 5 minutes or so to take a look at this code and see if you can explain why it's perfectly working well. All right, so let's try and explain this. Does anyone have any theories as to why this works? Yeah, very good.
Adding the character to the string each
Yep.
time. So first round it will just, X, sorry, D, but then it'll add E in front of D and then.
Exactly. So what's sort of magical about this code in particular is the reverse ordering of this. Whenever you see code that looks like this, you have to wonder why they put car first and not second. Okay, so let's go through what that actually looks like. So in this case here, we have reverse string. So we create the reverse string first. Okay. And then for the character, we're going to add the reverse string equals to character plus reverse string. Okay, so in this case, we're going to add the S and it just looks the same. Okay. And then we add the T, okay? And then the R, and then the E. And see how we're adding the character at the start of the reverse string every single time. Okay, so that's that section there, which is we add the character to the old reverse string. Does that make sense? And so that's how this code works. All right, so some exercises which you can do at home if you'd like. Now we're going to go through this for the next 10 minutes and then you can go out to lunch. But so how would you build a program to flexibly search for certain strings? So obviously when we're dealing with strings, right, there's some cases where you need to find exact words. So when you control F something, right? But sometimes you don't know what the word actually is, or you don't know what the type is, but you know the format. So for example, you might know in a paper or research paper that they refer to the word rotate or rotated or rotating or rotation, but you don't know which one, right? Or you might have a list of email addresses and you want to find specifically anyone from Monash, right? So you see how it's flexibly searching. Or you might have a list of international mobile numbers and you want to find Australian mobile numbers in particular. Okay? So does anyone have any ideas about how to do this?
Second, say if like monash.edu is in again email, like
Yeah.
4 emails,
Yeah.
one list of email. The first one, I think you do 4 rota, something like that.
That's- yeah.
If that's like every single.
Perfect. So what if, for example, you have a list of emails, but you have staff emails and student emails, and they have completely different formats?
Crazy 4. If at student.monash.edu.
Okay, sure, okay. What if it's a, I forgot about the student.monash thing. What if, say, the students just have at Monash?
Well, and I want to split. Oh, then what?
Yeah.
Well, students have student IDs.
Yeah.
The teachers don't.
No, but you don't have IDs in this.
What's the functional difference? What is the?
Like,
What's the
based on
difference?
the child, like, I wouldn't know the difference if I say actually took this.
Yeah, so we can provide an example. So
Oh,
for example, mine is my
dictionary.
first name dot second name, right? Well, your student ones are, I believe it's like the first letter of your first name, first 3 letters of your last name or something, and then 4 numbers, right? Yeah. We'll see. Anyone know?
A lead up for dictionary.
No.
Uh,
Close. All right, so I'll just go through it. So there is this very powerful way to search in Python and in other languages as well called regular expressions, which is you basically flexibly string match using special operators. Okay, so for example, the caret there means starts with, the $ means ends with, and we'll go through some examples. The star or asterisk means 0 or more occurrences of something, right? The plus means 1 or more occurrences of something. A dot means any character. And for example, that square bracket A to Z means that any character within this set. Okay, so anything that's, for example, a capital, uppercase or lowercase letter. So let's go through some examples here. So this is actual working code that you can use in Python. Python has a module called RE, which stands for regular expressions. You import RE, and then you call the regular expression, so regex in this case, equals caret HE. And then you can match the regex that you've defined with, for example, a specific string and see if it returns true or not. Okay, so technically match actually doesn't return a Boolean, but it returns an object that tells you that it matches. Okay? So if you run this code, which ones will return true or match object? Yeah.
for my math.
Exactly. So let's go through that, right? So this caret means start with. Okay. So does it start with the letter H and the letter E? Okay. So yes, yes, no, no, because it's a capital H, and then no. Okay. All right. What about this?
Ah,
Okay, so any guesses from this table? The bottom one would match. Yep, perfect. So let's go through the example. So the caret means starts with, dot means any character, so it accepts any character. E it has to be the second letter though. So it will accept hello, hello with the exclamation mark, jello, because J is in character, right? Capital H is also in character, so we'll accept that hello as well. And then it wouldn't accept the exclamation mark because it doesn't fit that structure. Does that make sense?
So the E has to be doing something.
It has to be the second one. Yeah. Okay, perfect. What about this?
That any alphabet with uppercase or
Uppercase, exactly. Yep, so just say it here, but if you like to share it.
Yeah, so just be the.
Exactly. So this one here, it says starts with, and then we say any alphabet that happens to be a capital letter. Okay, so in this case, the only one that fits is the capital H letter. Yeah,
We did that with numbers.
you can do it with numbers, yeah, you're in. Okay, perfect. What about this one?
Zero constant.
It's in the zero.
It's zero plus is inclusive. Sorry?
Oh, okay, so you put the, dollar sign after the character.
Yes. The dollar sign is the end of the characters at the start.
So like you put the dollar sign in this, you put the dollar sign next to the very last character in the red jack. To indicate the character for the dollar
Yeah,
sign, that one, okay. Alright. So it means the end of the if that's the include.
So it's really
Read that.
It starts with
It's not to
the
the
character, it has a
Or-
unity point and it ends with the character.
Oh, Yeah, it's a good question. So in this case, the asterisks are last. And then the carrot is last. Yeah, quite generally. So generally the asterisks are last. Is what?
Yeah. Be a lot of.
Yeah. Okay, so let's go through this one. So there are some special things you need to know for this one. So the caret means that it applies to whatever occurs after the caret, okay? The asterisk applies to whatever comes before it, okay? And then the dollar sign applies to whatever comes before it. Does that make sense? So let's go through what that means. So caret means that it has to start with any character. However, that any character can be 0 or more occurrences, inclusive, okay? And then we have an exclamation mark that it has to end with. Okay? So which ones would apply or which ones would return true? Yeah. 2 and 5, exactly. Okay. So what this extras here means is that you can have any number of characters that you want, including 0, as long as you end with an exclamation mark, we're good. Okay, so obviously not anything without an exclamation mark is out of practice, right? But this one here is acceptable and this one here is acceptable. Does that make sense? What if, yeah.
Just the last two schools that gets affected, right?
Yeah, I think that gets tricky in that, let's see, so
And
and it
next
has to end with
line.
an exclamation mark. So it's just the last one I think would apply because it doesn't accept any other character before that.
And
Makes sense,
that's
yeah. So you
saying
have
like
to
if no
specify
other
the
characters
characters in your
were-
characters. Okay, Right. What if, for example, we change it to this? A plus instead of an asterisk. So in this case, the asterisk, remember that it means 0 plus occurrences, okay? The plus now means 1 plus occurrences, meaning that there must be a character at least 1 before the exclamation mark. Does that make sense? So in this case, we would only highlight this one here. Okay, so let's try your hand with some examples here, real quick before lunch. So write a regex function that accepts a Monash staff email. So for example, that and returns true if it is and false if it isn't. Import RE. Yeah. Yeah. Yes, so that's what I'm saying. So it doesn't return the, it returns a match. So
Oh,
it
okay.
tells you that it's matched. At the end.
Okay, so it's not going to show me.
Yeah, it's not.
Yeah.
Okay, so I'll go back to the list of stuff here in case you need it. So a staff email, right? So quad.cal@monash.edu. That's the structure of a staff email.
We have the square brackets in the sheets.
Square bracket the end of letters if you want to.
Yeah,
Is that right? So it depends on any character and lots, but if it's, for example, like forms then you can square bracket that inside. So actually, you think about it, it's not necessarily, there's a, also specific like.
Is it at one?
Yeah.
Oh, I can do that.
So for example, if you want the word Monash, you can simply put the word Monash inside. Right, if you want to force the word Monash.
Any character, any number of characters. Yeah. And then this forward slash token.
Yeah.
Yeah, that's right. And same thing
Uh,
with your last name.
Right?
Yeah.
So see if it works actually.
Yeah.
Yeah, yeah. And you gotta have the budget. Yes. See if you can be specific. It says, yeah. So if you try and run it, you will get a match object. So remember that doesn't return what it is. It tells you match object. If it fails, it will say nothing. Yeah. Yeah. Yeah, so.
Unternamed being legal. What? I thought none.
But yeah, that just.
Said it.
Yeah, so the other thing is. I like, yeah. And given one that- yeah. what was that? Yeah, yeah, yeah. So think about it. Yeah, also we've got- That's pretty good. Yeah, so you have this. So one thing to be thinking about, yeah.
You can say what
Yeah, one thing to be thinking about is when it's quad.cal, you want to make sure that the dot you're using doesn't refer to any character, right? And the way to do that is the escape character. Remember? So it says to treat it as part of your object, right? So part of the string of the special. Okay? So make sure that you have an escape character before the dot to account for that 5 dots count. Because if that dot is technically a character, it is not as strict as the dot count.
Saying match or? Okay, let's do it. But-
Yeah, that makes sense. If it's wrong, then it will return.
Yeah.
Oh, okay, that's wrong. Yeah.
You got one right on the, so I see this right. It's put the flag right, you put the dot up there. Ah, where back? No idea. It makes sense. Start with any character as long as once, and then it has to have literally, and it's the same thing, it has to have character, and then technically, and it has to have. Like doesn't every single.
Try
email
to
have
stress test
first
your
name,
font.
last name?
So like.
I just think
this,
thank you.
stress test.
Time is set from Bob. That's you need it. If I haven't, I don't want.
It's rude. Is it? I don't think it's stopping on that. Yeah. So if you want to stress test your function, right, try like exclamation mark, dot pound at monash.edu and see if it works. And if it works, then it's well, right?
Ah.
Yeah.
Yeah, Barbara, don't and that.
That's.
Wait.
No.
Yeah. It's actually working stuff before. This actually, before I had a period, and it worked in the period before, which means it's unbound. So we can have any character, as a zero or more, any character, which is any. And then it has to eventually. This dot will be inside right now. So I don't want to refer to the dot that means. You put black sides off of the plane.
And then the zero plus after zero also every time and some any time every zero
All right. Good.
Okay, so let's take a look at what this actually looks like, right? So this is obviously a very tricky thing to deal with. So there are lots of different ways to do this, but this is the way that I did it, right? So what we're starting with is we say the caret, which means that we start with anything from A to Z, right? So A to Z, meaning that we have lowercase, because I can point our staff emails are all lowercase, right? And then we have the plus there, which means that it's one or more occurrences of any letter. So for example, you can't put in dot and then surname at monash.edu, that wouldn't work. Does that make sense? So it has to start with someone's first name. So it's like $5.cow, but .cow just doesn't work. Okay? And then we have the escape character, meaning that this dot doesn't mean any character, but it actually is just literally a string, right? So the dot must be in place. And then we have A to Z plus again, meaning that there has to be a surname that's in place that's all lowercase and consists of more than one character, one or more characters. Okay? And then we have ends with, so the $ at monash.edu.
that make sense? Okay, now this is a common structure that I've seen, and let's try and break it down. So let me document camera up. So in this case here, if you take a look at that function on the left, we have def, and then I'll just say func here, email. If rematch regex email, return true, else return false. Now, this function has this unusual behavior, right? Where if you, for example, use this, if you write this out, it actually returns a Boolean, as you can see, right? But when you try it by itself, this returns a match object, okay? If it's true, and then it returns none if it's false. Okay, so it's a bit of an unusual function. Now, this is a very useful sort of thing to be aware of, but say you have if condition. Return true, else return false. So that there, you see that? Perfect. What's a way to write this in a single line? Yeah. Yes, exactly. So this is a very common structure that you might see in your code, and a much easier way to write it is to simply write return condition. Okay, and let's think about why. So this we know is a Boolean, right? This will either evaluate to true or false. Okay, with meaning that this here is either going to return true or false. And if this is true, it automatically returns true. And if it's false, it automatically returns false. Does that make sense? So this piece of code here is actually unnecessary. Okay, because if it's true, it will always return true. And if it's false, it always returns false. And it already does so in this single line. Does that make sense? Any questions about that in particular? Okay, great. All right, so let's break for lunch. So let's be back at 2. If you'd like as a challenge, you can try to write a regex to see if you can return a student email. But some really cool things that you can use with regex is /v equals digits, right? And then this indicates that you want exactly 3 of something. Okay, so if you think about it, your student emails are exactly 4 digits. It would be \d and then squiggly bracket 4. That indicates that you want exactly 4 digits. Okay.